talk to you a little bit about Desmos in this video. Desmos is an online graphing app. There are also apps available for iOS devices and probably for Android devices, although I don't own an Android device, so I can't speak to that. I'm going to be showing you this on the web application in this demo. I'm using Chrome on my MacBook, but in other videos where you'll see me use this app, I'll be using the app on my iPad, but the interfaces are almost identical. In fact, I chose to use the app on the web today because then you can see my mouse clicks with the cursor, right? All right, so we're going to start by just naming the graph. So I'm going to click on that untitled graph up in the corner, and I'm going to write, we'll just call this brief tutorial. All right, and we'll save that. I have an account with Desmos. I suggest that you get an account with Desmos. There's no cost. You just sign up, and then once you have an account, when you're logged in, you can save your graphs to the Desmos server, and they're sitting there on the web if you want to pull them back up and use them. We'll start by just defining a note here, just so I could show you kind of what the note thing does. Brief tutorial. All right, and then below that, we're going to create a folder, and we'll call this linear equation, and we're going to call it that because we're going to define a linear equation. All right, so down here, I'm going to actually define something that we can plot. I'm just going to define an equation using the point slope form of a linear equation. So mx plus b. Now I'm using my keyboard. You can just as easily use the keyboard down here, switch over to letters B. There we go. All right. And now when I write that, it asks me, do I want to define a slider for m and b? So Desmos is understanding y and x to be variables, and it's thinking that m and b are constants, and it's saying, okay, well, do you want me to define sliders for those constants? And yeah, I do want that, so I'm going to click all right? So now I have the line displayed, right? And I can change the slope by futzing around with the slider, and I can change the y-intercept by futzing around with the slider for b, all right? All right, good. So we've defined a linear function, right? So I'm going to put each of these components of my linear function under the folder that I defined, the linear equation folder, and then I'm going to close that folder. Now, if I want it to stop displaying, I'll just click on the folder icon there, and it stops displaying. All right, let's define another folder, right? We defined a linear folder. Now let's define a quadratic folder, quadratic equation. All right, and now I'm going to define a generic quadratic equation. So I'm going to say ax squared. Now, when I do the squared, right, I could have gone down here and said, okay, there's x. I hit the a squared button, and that makes it squared. What I did actually do, I didn't do that the first time. What I did is I typed x on the keyboard, and then I typed the up caret 2, and Desmos interprets that to mean I want to square x, right? So I'm going to do plus, now I'm going to do b. Now I've already used b in my linear equation, so I'm going to make this b1, right? So I just typed 1 after the b, and Desmos says, I'm going to interpret that as a subscript for b, and that's what it did. B times x plus c. And I want, of course, all this to be equal to y. So I'm going to go back over to the beginning, type y equals, and I have a quadratic equation. And Desmos wants to know if I want to define sliders for the constant a, the constant b1, and the constant c. And the answer is, yeah, I want to do that. And there I have it. Now I can futz around with these constants, and I can change my parabola. All right, let's put each of these elements of my quadratic equation under the quadratic equation folder. All right, and I'm going to close the folder. I'm going to leave it turned on, though, because I'm going to be expanding what I'm doing with that quadratic equation in the following way. I'm going to define a folder for real roots of the quadratic. So I'm going to come down here, and now the roots are found using the quadratic formula. So I'm going to say my first root, I've got two roots, right? Quadratic equation, two roots. x1 equals, I'm just going to write here the quadratic formula, which is negative b divided by 2 times a. And remember, I used b1 for b, so I'm going to go up here and just make that a b1. All right. And it's going to be plus square root. Now to put square root in here, I'm just going to type SQRT. Desmos knows, yeah, the guy wants to use square root. So it's going to be b1 squared minus 4ac, and I'm going to arrow out so it knows to divide the entire expression under the radical by 2a. All right. Okay, so that's my first root. Now, I want a very similar expression for my second root, right, except I want the plus here to be a negative. So rather than retype all that stuff, I'm going to go to my, my little gear icon here. I'm going to click on that. I'm going to come down here and duplicate that expression. I'm all done. All right, and now I want this to be the second root, so this is going to be a negative. It's the second root, so I'm going to make that 2. And there I have it. I have my two roots for my quadratic equation. Now, I can't really see those. Well, not really. I can't see those at all over here. So let me define an equation that will allow me to visualize the root. So I'm going to say that x equals x1, and that draws a line right there at x1. And then here I'm going to say x equals x2, and that draws my other line. Right? Now, I'm going to change the color. So I'm going to go to the gear icon here. And I'm going to make that the same color as my quadratic, but I'm going to make it a dash line. And down here, same thing, same color, dash line. All right? All right. Let's put all these under the real roots folder. And then before we leave the real roots folder, I'm just going to put a point at each of the root locations. So my first point is going to be x1. And my y value, of course, is 0 because that's what the root means. And then come down here, and I do the same thing for x2. All right, and there I have 2 points lying on the y-axis at the x value of my two roots. I'm going to add those to the folder, and now I can collapse the folder. All right, great. Now, let's just add one more point to our quadratic equation, and I'm going to define another folder, and I'm just going to call that other point. All right? And what other point do I want? Well, I want a point that defines some arbitrary point on my parabola. All right? So I'm going to define a value x sub p. I'm going to go over to the letter keyboard, and I'm going to type this a sub b key, which you can't really see in the screen. It's on the bottom left of the keyboard. That lets me do a letter subscript to my variable a. I'm just going to call it p for x point. All right, and then a comma, and I'll put my y value, yp. All right, all right, and I'm going to close the parenthesis. I'm not going to add sliders here because I'm going to define yp in a different way. So let me just go back up to my quadratic equation. And let me duplicate my quadratic equation. Duplicate. Drag that down here. So I'm done. I'm going to close that back up. And what I'm going to do is I'm going to say y sub p is equal to a times x sub p plus b1 x sub p. All right, and I'm now going to add a slider for xp, move that down here. All right, and now you'll see down here, I have a point on my parabola, and as I change the value of x sub p, that point follows along the parabola, all right? And I can figure out, you know, what's the y value for negative, for x equals negative 0.8. Well, it's up here, yp equals 6.172, and that's what I find over here. All right, so let me just put this under my other point folder, and let me close that up. All right, now let's turn off all of my parabola plots here. I'm going to make a different folder here called functions, and that will allow me to show you how Desmos handles functions. All right. So say I want to plot y equals cosine x. So I'm going to write y equals, now I can type cosine x here, and Desmos understands that. And you see there's the cosine function. All right. Or I can go over here to the function toolbar, and here are all my trig functions, my inverse trig functions, my hyperbolic trig functions, as well as a bunch of statistics functions and a bunch of miscellaneous functions. Here I have a natural log, common log, exponential function, derivative, integral, summation, product. All right, let's go back to trig. We'll plot cosine. I'm going to make cosine x. All right, there we go. All right, that's a little bit about how to utilize the predefined functions in Desmos. Let's close that up, turn that off. One more folder. We're going to call this folder implicit function. Now, most of the functions that you've probably dealt with in the past have been explicit functions. And most of the functions that we'll deal with in this course are explicit functions. Right? By an explicit function, I mean this. Right? Y, for instance, is a function of x. Nothing magic about y or x, right? But y as a function of x would be something like, I don't know, 3x, right? A line, right? Or maybe x as a function of t is equal to 5t, all right? All right, those are explicit functions. We're defining y in terms of some function of x. We're defining x in terms of some function of t. Now what I'm going to show you is an implicit relation. It's not really a function because it fails the vertical line test. So even though I wrote the folder to say implicit function, what I'm going to show you here is an implicit relation. So we're going to say y squared plus x squared equals 6. I have not defined y in terms of x. I have not isolated y on one side of the equation, right? So this function is written as an implicit function. As it turns out, it's the function for a circle. You see the circle plotted here. And just to play around with this a little bit, I'm going to add some constants, a constant in front of the y term and a constant in front of the x term. So I've already used a, b, b1 and c, so I'll use d here. And in front of the x term, I'll use f. I'm going to define sliders for d and f. And now I have the ability to change the equation for a circle into the equation for an ellipse. All right? An ellipse, or a hyperbola. All right? All right. I'll just put this under my implicit function folder. All right, there you have it. So we have talked about implicit functions, predefined functions in Desmos, quadratic equations, and doing some kind of neat things with a quadratic equation. And then we started with a linear equation. All right, so I really encourage you to go to Desmos on the web and play around with it. And maybe you just want to take a look at this video in one window while you're playing with Desmos in the other window so you can get a feel for how Desmos works yourself. Now, we can go ahead and save this file by simply hitting the Save button up here, and that will save the file on the Desmos server, and you can see it's saved here. You can see all of the other files that I've defined in Desmos. I told you at the beginning of the video that I generally run the Desmos app on my iPad, but I wanted to show you that you can run it on your phone. This is on my my iPhone. To me, it's a little bit small, but you can certainly see that you can display graphs this way. Here I'm manipulating the slider for the point on the parabola. All right, great. See you in class or in the next video.